Hello friends, in this video we will study relation between f and r, where f is the focal length of the concave mirror and r is the radius of curvature. Now for this figure we can say that pf is f, which we have written over here, and pc is r, which also we have written over here. Now basically what we have to prove over here is that f equals to r by 2, or in other words, this point F lies at the center of this line segment PC. So how do we do that? So let's proceed. Let's consider an incident ray parallel to the principal axis striking this mirror, say at point A. Now after reflection, the reflected ray will pass through the principal focus like this. Okay. Now from C, if I connect A, the CA will act as a normal to this concave mirror, because see, for any spherical surface, the radius of that surface is always normal to its surface. So over here, the CA is acting as a radius for this spherical concave mirror. Fine. Now, this is angle of incidence I, this is angle of reflection R. So obviously, from the law of reflection, I can write I equals to R. This we have got from law of reflection. Also in this figure, say if this angle is alpha, angle ACF is angle alpha, I can write angle alpha equals to angle I. This angle equals to this. Why? Because they are alternate angles. Both the angles are alternate angles. Okay? Now since alpha equals to I and I equals to R, so obviously we can say that angle I equals to angle R equals to angle alpha. Now consider triangle CAF. Now in this triangle CAF, if you see that alpha and R, these two angles are equal, so obviously the sides opposite to these angles, that is CF and FA, these two sides will also be equal to each other. So I can write over here from triangle CAF, we can conclude that CF equals to FA, since R and alpha both are same. Now, this entire figure which we have drawn, for this figure, what we have considered that the aperture, that is the size or the diameter of this mirror, is very small. Okay, remember in this you can write down a note that the aperture of mirror is very small. Now since aperture of the mirror is very small, now what will happen? This point A will lie very close to point P. That means A and P will be very close to each other. Now what happens because of this? Now if A and P are very close to each other, we can say practically this FA would be equal to FP. Okay, since A is lying very close to P, so we can write FA will almost be equals to FP, since A and P are very close to each other. Now from these two relations, we can conclude that CF equals to FP, because CF equals to FA and FA equals to FP. So we can conclude that CF equals to FP, or we can say that R is nothing but CF plus FP. This would be equal to 2 into FP. And what is FP? FP is nothing but small f, that is the focal length, So I can write R equals to 2F or F equals to R by 2. Now this also concludes, or this also proves the relation that this point F lies in the middle of this line segment PC.